Okay, so this is going to be a video on taking the derivative of arc cosecant of x. So in the top left corner here, I wrote arc cosecant of x equals y. If you take the cosecant of both sides here, you will just get x equals cosecant of y. I just flipped it around to cosecant of y equals x, so it comes out in a more preferable way. And then, of course, I wrote the Pythagorean identity below that. I suggest you watch previous videos on the other derivative of inverse trig functions because the path of which I derive these is pretty much the same, and you should probably have some idea if you want to try and do this yourself before I do it, because it's not too hard. All right, so I'm going to use implicit differentiation to take the derivative of both sides of cosecant of y equals x. So I'm just going to write the operator d over dx on both sides here. So d over dx cosecant of x, or cosecant of y, I'm sorry, equals d over dx of x. The derivative of cosecant of y is going to be negative cosecant of y times cotangent of y times dy over dx. And then the derivative of x is just 1. Okay, I want to isolate this dy over dx, so I'm going to divide both sides by negative cosecant of y times cotangent of y, and I will have dy over dx is equal to 1 over the negative cosecant of y times cotangent of y. Okay, and then I'm going to do dy over dx equals, and if you'll notice, cosecant of y up here, we wrote equals x, and down here we have a negative cosecant of y. So I'm going to write 1 negative here. I'm going to write negative x times cotangent of y, right? So that's negative 1 over x times cotangent of y. All right, and then I want to figure out how I can express cotangent of y in terms of x. So that's when I look over here at this Pythagorean identity. What I want to do is find a way to say cotangent of y equals. And right off the bat, I'm going to divide everything here by sine squared of y. So what that's going to do is give me 1 plus cotangent squared of y equals, and 1 over sine squared is going to be cosecant squared of y. Okay, so I have this 1 plus cotangent squared of y equals cosecant squared of y because I divided everything by sine squared of y. Now what I'm going to do is I'm going to isolate cotangent squared of y, and I'm just going to say cotangent squared of y is equal to cosecant squared of y minus 1. And then I'm going to take the square root of both sides just to get that cotangent of y. And that we will have equal to cosecant squared of y minus 1. Okay, now I can input this cosecant squared of, or well, the square root of the cosecant squared of y minus 1 into this cotangent of y because they're equal to one another. But I'm going to skip that step because if you look closely, you can see cosecant squared of y. You see up here, cosecant of y is equal to x. So cosecant squared of y is just cosecant of y times cosecant of y. In other words, x times x, which is just x squared. So I can write this all as 1 over, the negative 1 over x times the square root of x squared minus 1. And we're not quite done yet. Now, if you look over here at the graph I made down here, the bottom left of arc cosecant of x, that's all that is. That's the graph of arc cosecant of x equals y. You'll notice, contrary to arc secant of x, this graph is always negative rather than always positive, right? So the derivative must always be negative, right? The slope is always negative. So if you look over here, you'll see that there's this negative in front here. So that's good, right? We have negative 1 over x times the square root of x squared minus 1. But what if x itself is negative? Then we're going to have a positive square root, and that is an issue. So similarly to how we had the arcsecant of x, how we did the absolute value, we're going to do the same thing here. And that way we can ensure that the derivative is always going to be negative. And then we're pretty much good to go. So I'm going to just take this. I'm going to say, just going to write this just to finish it up, dy over dx is equal to this. If you remember here, we have y is this. So if we're taking the derivative with respect to y, then we're getting the derivative of arccosecant of x. And therefore, that the derivative of arccosecant of x is equal to -1 over the absolute value of x times the square root of x squared minus 1. I hope that was helpful for anyone watching. Thank you.